Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. Hilbert's Hotel Paradox. A hotel with infinitely many rooms, each numbered with a positive integer, 1, 2, 3, and so on without end, stands fully occupied. Every room contains a guest, and yet when a new guest arrives, the manager is not concerned, does not turn them away, because infinity accommodates addition in ways that finite quantities cannot. And the manager simply asks each current guest to move to the next room. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3, and so on, each guest shifting one room higher. And this process, applied simultaneously to all guests, leaves room 1 vacant, and the new arrival is accommodated without displacing anyone permanently. And this is Hilbert's Hotel, a thought experiment devised by the mathematician David Hilbert to illustrate the counterintuitive properties of infinite sets, to show that infinite collections behave in ways that violate ordinary intuition, that they can be put in one-to-one correspondence with proper subsets of themselves, that adding elements or removing elements does not change their cardinality, and that the whole is not always greater than the part when dealing with infinity. The paradox deepens when an infinite number of new guests arrive, an infinite bus pulling up to the hotel, each passenger needing a room. And again, the manager is unperturbed, because there is a strategy to accommodate everyone. The manager asks each current guest in room N to move to room 2N. The guest in room 1 moves to room 2. The guest in room 2 moves to room 4. The guest in room 3 moves to room 6, and so on. And this process places all the original guests in the even-numbered rooms, leaving all the odd-numbered rooms vacant. And since there are infinitely many odd-numbered rooms, one for each positive integer, there is exactly enough space for the infinitely many new arrivals, who are assigned to rooms 1, 3, 5, and so on. And the hotel, despite being full, has accommodated an infinite number of additional guests without anyone being displaced. The paradox reveals that infinite sets have a property called countable infinity. They can be placed in one-to-one correspondence with the natural numbers, and this correspondence allows for operations that seem impossible with finite sets. A fully occupied hotel with finitely many rooms cannot accommodate additional guests without evicting someone. But a fully occupied hotel with infinitely many rooms can accommodate not just one additional guest, but infinitely many. And this does not mean the hotel was not really full before. All rooms were occupied, but rather that fullness does not prevent expansion when infinity is involved, that the concepts of full and empty take on new meanings in the infinite context. Hilbert's Hotel also allows for even stranger scenarios. Suppose infinitely many infinite buses arrive, each bus containing infinitely many passengers, and the hotel must accommodate all of them. And again, there is a strategy. The manager can use a pairing function, a mathematical technique that assigns a unique room number to each combination of bus number and seat number, ensuring that every passenger gets a unique room. And the hotel, starting from full occupancy, can expand to accommodate not just countably many new guests, but countably many groups of countably many new guests. Because the union of countably many countable sets is still countable, and so the total number of guests, after all the buses are accommodated, is the same cardinality as the number of guests before. Both are countably infinite. Both can be placed in one-to-one correspondence with the natural numbers. The paradox challenges intuitions about size, quantity, and comparison, because it shows that infinite sets can be proper subsets of themselves and yet have the same cardinality. The even numbers are a proper subset of all natural numbers, missing all the odd numbers, and yet there are just as many even numbers as natural numbers. Both sets are countably infinite, and this violates the Euclidean principle that the whole is greater than the part, a principle that holds for finite sets but fails for infinite sets. And this failure is not a contradiction, but a distinctive feature of infinity, a marker that distinguishes finite from infinite. Hilbert's hotel also raises questions about the physical realizability of actual infinities, because while the mathematics of infinite sets is well defined and consistent, whether actual infinite collections exist in the physical world is contested. Some philosophers and physicists argue that only potential infinities exist, processes that can continue indefinitely but never reach completion, while actual infinities, completed infinite totalities, are merely mathematical. Abstractions and the hotel paradox, with its fully occupied infinite structure, represents an actual infinity, and if such infinities cannot exist in reality, then the paradox is merely a mathematical curiosity without physical significance. But others argue that the universe may be spatially infinite, that time may extend infinitely into the past or future, and that quantum field theory involves infinite dimensional spaces. And if actual infinities are physically real, then the strange properties illustrated by Hilbert's hotel may have real-world counterparts. The hotel also appears in theological discussions about divine attributes, because an omnipotent being might be thought to perform tasks that involve manipulating infinite collections. And Hilbert's hotel shows that such manipulations are logically coherent, that infinity does not lead to contradiction, that an infinite hotel can be fully occupied and yet accommodate more guests. And this addresses worries that infinity is inherently paradoxical or incoherent, demonstrating that infinite structures follow consistent rules, even when those rules differ from finite intuitions. The hotel stands infinitely tall, infinitely long, each room numbered, each room occupied, and the new guest arrives. And there is room, always room, because infinity plus one is infinity, because infinity plus infinity is infinity, because the operations of addition and union that exhaust finite resources leave infinite resources unchanged, and the paradox reveals the strangeness of infinity, the way it defies expectation, the way it makes possible what seems impossible, and Hilbert's hotel remains one of the most vivid and accessible illustrations of this strangeness, a story that captures in simple terms the profound weirdness of the infinite. And mathematicians use it to teach, to explain cardinality, to distinguish countable from uncountable infinities, to motivate Cantor's diagonal argument and the hierarchy of infinities. And philosophers use it to probe intuitions about existence, about the difference between actual and potential infinity, about whether the physical world contains or could contain infinite structures. And the hotel endures, a fictional place that illuminates real mathematics, a thought experiment that has become a permanent fixture in discussions of infinity, a paradox that is not a contradiction, but a revelation, a demonstration that infinity is not merely a large finite number, not merely an extension of ordinary quantity, but something qualitatively different, something that requires new concepts, new intuitions, and new ways of thinking about size, about number, about what it means for something to be more or less equal or unequal, full or empty. And the guests check in, infinitely many guests, and there is always room for more. Fichte's paradox of knowability. There is an appealing idea in philosophy, a principle that seems to capture something important about truth and knowledge, and this is the knowability principle, which states that all truths are knowable, that for any true proposition there is at least a possible situation in which someone knows that proposition, and this principle seems modest, even Platonic in spirit, suggesting that truth and knowledge are intimately connected, that reality is not fundamentally hidden or inaccessible, that the universe is intelligible in principle, even if not all truths are actually known by anyone at any given time. The principle distinguishes between what is known and what is knowable, acknowledging that many truths remain unknown, perhaps because no one has investigated them, or because the evidence is lost, or because the relevant questions have not yet been asked, but insisting that these unknown truths could be known, that there is no barrier in principle preventing them from being discovered. And this seems like a reasonable position, neither too strong like the claim that all truths are actually known, which is obviously false, nor too weak like the claim that some truths are unknowable, which seems to concede too much to skepticism and to suggest that reality contains secrets that are forever beyond our reach. But in 1963, Frederick Fitch proved a shocking result, a theorem showing that if the knowability principle is true, then all truths are actually known, that the modest principle collapses into the absurdly strong claim it was meant to avoid. And this result, known as Fitch's paradox or the knowability paradox, has profound implications for epistemology, the philosophy of language, and debates about realism and anti-realism, and it forces philosophers to choose between giving up the knowability principle, accepting the absurd conclusion that all truths are known, or finding some way to reformulate the principle to avoid the paradox. The proof is elegant and surprisingly simple. Proceeding by reductio ad absurdum, suppose there is a truth that is unknown, call it P, and suppose also that no one knows that P is an unknown truth. That is, no one knows the conjunction P, and P is not known. And now apply the knowability principle, which says that this conjunction, being true, must be knowable, must be such that someone could know it. But here a contradiction emerges, because to know a conjunction, one must know both conjuncts. So to know P and P is not known, one must know P and also know that P is not known. But if one knows P, then P is known, which contradicts the second conjunct that P is not known. And so the conjunction P and P is not known cannot be known. It is an unknowable truth, and this contradicts the knowability principle, and therefore the assumption that there is an unknown truth must be false, and so all truths must be known. The paradox depends on the assumption that knowledge distributes over conjunction, that if you know P and Q, then you know P and you know Q, which seems uncontroversial, and on the assumption that knowledge is factive, that if you know P, then P is true, which is a standard requirement in epistemology, and so the paradox cannot be easily dismissed as relying on dubious principles. It seems to follow from our ordinary understanding of knowledge and knowability, and yet the conclusion is unacceptable. The claim that all truths are actually known is empirically false. There are obviously truths about the distant past, about the far reaches of the universe, about the inner workings of consciousness that no one knows. And so something must give, either the knowability principle or the reasoning that derives the paradox from it. One response is to reject the knowability principle, to accept that there are unknowable truths, truths that could never be known by anyone under any circumstances. And this is the position of semantic realists, who argue that truth is independent of our capacity to recognize it, that reality outstrips our epistemic abilities, that the world contains facts that are forever beyond our ken. And for realists, the knowability paradox is not a disaster, but a vindication, a proof that the anti-realist commitment to knowability is untenable, that we must accept a more robust conception of truth as radically independent of knowledge. Another response, favoured by anti-realists and verificationists, is to reformulate the knowability principle to avoid the paradox while preserving the intuition that truth and knowability are connected, and various reformulations have been proposed. Some restrict knowability to propositions that do not involve knowledge ascriptions, avoiding the problematic self-referential structure of P and P is not known. Others distinguish between individual and collective knowability, arguing that all truths are knowable by the epistemic community as a whole, even if not by any single individual, and still others embrace a temporal or modal reformulation, claiming that all truths could have been known at some time or in some possible world, rather than claiming that all truths are actually knowable in all circumstances. Some philosophers argue that the paradox reveals a tension in the concept of knowability itself, that knowability is not a simple modal notion, but involves complex interactions between truth, knowledge, and the conditions under which knowledge is possible, and that our intuitions about these interactions are unreliable, pulled in different directions by competing commitments, and so the paradox exposes an instability in our conceptual scheme, rather than refuting any particular philosophical position. The paradox also connects to debates about the nature of propositions and the objects of knowledge. Because the problematic conjunction P and P is not known seems strange, it is a proposition about itself in a way, a proposition whose truth depends on whether it is known, and this self-referential or quasi-self-referential structure is reminiscent of the liar paradox and other semantic paradoxes, and some responses to Fitch's paradox draw on strategies developed for dealing with those paradoxes, such as hierarchies of languages, restrictions on self-reference, or non-classical logics that reject certain principles like the law of excluded middle. The paradox has implications for constructivism in mathematics and logic, because constructivists typically endorse some version of the knowability principle, identifying truth with provability or constructibility, and Fitch's paradox threatens this identification, suggesting that even constructivists must either accept that all mathematical truths are already proved, which is absurd, or abandon the simple identification of truth with provability and develop a more nuanced account of the relationship between the two. The knowability principle, innocent as it seemed, turns out to be a Trojan horse, a seemingly modest claim that conceals a radical commitment, and Fitch's paradox forces philosophers to confront the costs of various epistemological positions, to choose between realism with its unknowable truths and anti-realism with its need to reformulate or restrict the knowability principle, and the paradox remains a central puzzle in contemporary epistemology, a test case for theories of truth and knowledge, a proof that demonstrates with crystalline clarity that even the most intuitive principles can lead to absurdity when their logical consequences are rigorously traced. And it stands as a reminder that philosophy is not merely a matter of articulating and defending intuitions, but of following arguments wherever they lead, even when they lead to conclusions that undermine the very intuitions that motivated them. And the unknown truth, the proposition that is true but not known, sits at the center of the paradox, both knowable and unknowable, possible and impossible, a conceptual anomaly that refuses to be tamed by logic or softened by reformulation. And the paradox endures, a monument to the power of formal reasoning, to reveal deep tensions in our most basic concepts, tensions that no amount of philosophical maneuvering has yet managed to resolve in a way that satisfies all intuitions and preserves all principles. And so the debate continues, philosophers proposing new solutions, new restrictions, new interpretations, and the paradox persists, waiting to trap the unwary, to challenge the confident, to remind us that even truth and knowledge, the twin pillars of epistemology, are stranger and more problematic than they first appear. Grandi's series, when adding numbers, forever gives multiple answers. A simple mathematical series begins with 1 minus 1 plus 1 minus 1 plus 1 minus 1, continuing forever without end, alternating between adding 1 and subtracting 1. And the question emerges, what does this infinite sum equal? What value does it approach as more and more terms are added? And the paradox is that different methods of calculation give different answers, each seemingly valid, each following mathematical rules, yet reaching contradictory conclusions. And this is Grandi's series, named after the Italian mathematician Guido Grandi, who studied it in the early 18th century. And the paradox reveals fundamental questions about what it means to sum an infinite sequence, about whether all infinite series have definite values, and about the limits of algebraic manipulation when dealing with infinity. Consider the series visually. Imagine a number line where you start at 0, then move 1 unit to the right to reach 1, then move 1 unit to the left back to 0, then 1 unit right to 1 again, then 1 unit left to 0, and this pattern continues forever, oscillating between 0 and 1, never settling down, never approaching a limit in the traditional sense, and so, from this perspective, the series does not converge, does not have a sum. The partial sums bounce between 0 and 1 eternally and never stabilize. But now consider a different approach. Group the terms in pairs, taking 1 minus 1 as the first pair, which equals 0, then 1 minus 1 as the second pair, also 0, and so on. And the series becomes 0 plus 0 plus 0, continuing forever. And the sum of infinitely many zeros is 0. And so by this grouping method, the series equals 0. And this seems like a valid manipulation. Grouping terms is a standard algebraic operation, and yet it produces a definite answer where the oscillating view produced no answer. Now consider another grouping. Start by leaving the first one alone, then group all subsequent pairs, so the series becomes 1 plus the quantity negative 1 plus 1, then the quantity negative 1 plus 1, and so on, and each grouped pair equals 0. So the series becomes 1 plus 0 plus 0 plus 0, continuing forever. And this equals 1, and so by this different grouping, the series equals 1 instead of 0. And both groupings seem legitimate. Both use standard algebraic rules, yet they produce different answers, 0 and 1. And this is the heart of Grandy's paradox, that the series is sensitive to how it is manipulated, that rearranging or regrouping terms changes the result. And this suggests that the series does not have a well-defined sum in the ordinary sense. Mathematicians have developed sophisticated tools to handle divergent series, like Grandy's, and one approach is Sabotage summation, which assigns values to series by averaging the partial sums. And for Grandy's series, the partial sums are 1, 0, 1, 0, 1, 0, continuing to alternate, and the average of the first n partial sums approaches 1/2 as n grows large, because roughly half the partial sums are 1 and half are 0. And so by Sabotage summation, Grandy's series equals 1/2, and this method produces yet another answer, neither 0 nor 1, but the midpoint between them. And this answer has a certain aesthetic appeal. It represents the average behavior of the series, the value around which it oscillates, and it can be justified by analogy to functions. If you consider the geometric series 1 minus x plus x squared minus x cubed and so on, which converges to 1 over 1 plus x for absolute value of x less than 1, and you plug in x equals 1, you get 1 over 2. And so in some extended sense, Grandy's series can be said to equal 1/2. The paradox reveals that divergent series do not have sums in the way convergent series do, that assigning values to them requires making choices about what summation method to use, and different methods give different results. And there is no single correct answer, but rather a family of possible values, depending on the context and the techniques employed. And this multiplicity is not a flaw in mathematics, but a feature, a recognition that infinite sums are more subtle than finite sums, that operations that work for finite cases can break down or become ambiguous when extended to infinity. Grandy's series appears in physics and engineering, in Fourier analysis, where oscillating sums arise naturally, in quantum field theory, where divergent series are regularized using techniques similar to Sabotage summation, and in signal processing, where alternating patterns must be analyzed. And in these applications, the choice of summation method is guided by physical considerations, by what gives useful predictions, by what aligns. With experimental results, and the paradox becomes less troubling, less a contradiction, and more a reminder that mathematical tools must be adapted to fit the problem, that formal manipulation must be tempered with judgment about what makes sense in context. The series also appears in philosophical discussions about infinity, about whether infinite processes can be completed, about whether the phrase, sum of infinitely many terms, has a determinate meaning or depends on conventions and choices. And Grandi's series suggests the latter, that infinity introduces ambiguities that finite mathematics avoids, that extending concepts from finite to infinite is not automatic but requires care, requires new definitions, requires acceptance, that some questions have multiple answers or no answer at all depending on how they are framed. Imagine watching someone walk back and forth on a path, taking one step forward, then one step back, then one step forward, then one step back, forever without stopping, and you are asked where they end up, and the answer is that they do not end up anywhere. They continue oscillating. But if you ask where they are on average, you might say they are halfway between the two endpoints. And if you ask where they are after an even number of steps, you say at the start, and after an odd number, you say one step forward, and none of these answers is wrong. Each captures a different aspect of the situation, and Grandi's series is similar. Different questions about the series have different answers, and the paradox arises from expecting a single answer when the situation is inherently ambiguous, when the infinite oscillation resists reduction to a single number. The series continues, 1 minus 1 plus 1 minus 1, terms alternating forever, and the sum is 0 or 1 or 1/2 depending on how you calculate it, depending on what method you use, depending on what question you're really asking. And the paradox endures, a simple series that exposes deep issues about infinity, about summation, about the limits of algebraic manipulation, and about the need for careful definitions when dealing with infinite processes. And Grandi's series remains a teaching tool, a cautionary tale, a reminder that infinity is subtle, that divergent series require special handling, and that mathematics is not just calculation, but interpretation, not just following rules, but understanding when rules apply and when they break down. And the series oscillates, forever unresolved, forever producing different answers, and the paradox persists, elegant and instructive, a monument to the strangeness of infinity and the care required when extending finite concepts to the infinite realm. Libet's experiments. Paradox: why your brain decides before you do. A neuroscientist named Benjamin Libet designs an experiment to investigate the timing of conscious decision-making, to discover when conscious intention arises relative to brain activity and action. And subjects sit before a screen with a moving dot like a clock hand, and they are instructed to flex their wrist whenever they feel like it, spontaneously, without planning in advance, and while they watch the screen, they note the position of the dot when they first become aware of the intention to move, when they first consciously decide to flex. And meanwhile, electrodes measure brain activity, specifically measure the readiness potential, a build-up of neural activity that precedes voluntary movements. And Libet's finding is striking and controversial. The readiness potential begins several hundred milliseconds before the subject reports conscious awareness of the intention to move. The brain activity precedes conscious intention by about 300 to 500 milliseconds. And this seems to show that the brain decides to move before consciousness decides. That unconscious neural processes initiate the action, and conscious intention is a kind of afterthought, an epiphenomenon, something that arises after the decision has already been made at the unconscious level. And this finding appears to challenge free will, appears to show that conscious decisions do not cause actions but merely accompany them or follow them. And this is Libet's experiment's paradox, the discovery that our conscious intentions come too late to cause our actions, come after the brain has already committed to acting. And this creates philosophical puzzles about the nature of volition, about whether we truly initiate our actions or merely become aware of them after unconscious processes have already set them in motion. Imagine the subject in Libet's experiment, watching the dot move around the screen, waiting for the urge to flex their wrist. and suddenly they feel the intention. They become aware of wanting to move. They experience the conscious decision, and they note the position of the dot. And a moment later, their wrist flexes, and this sequence feels like the intention caused the movement. Feels like they decided consciously and then acted. But the brain recordings tell a different story. Show that neural activity associated with the movement began several hundred milliseconds before the conscious intention that the brain was preparing to move, before consciousness knew about it. And this temporal order suggests that consciousness does not initiate action, but only monitors it, only becomes aware of decisions that have already been made unconsciously. And if this is correct, then conscious free will is an illusion, is a feeling that arises after the fact, after unconscious processes have already determined what will happen. The paradox is that subjectively, we feel like we consciously decide and then act, feel like conscious intention is the cause of action, but objectively, the neural evidence suggests that unconscious processes cause both the action and the conscious intention, that consciousness is not in the driver's seat but is a passenger, observing but not controlling, and this disconnect between subjective experience and objective reality creates the paradox, makes us wonder whether free will is real or illusory, whether we are agents who initiate actions or spectators who witness actions that our brains have already decided to perform. Visualize the timeline. At time 0, the readiness potential begins. Unconscious neural activity starts building up. At time 300 milliseconds, the subject becomes consciously aware of the intention to move. At time 500 milliseconds, the movement occurs. And the critical question is what causes what? Does the conscious intention at 300 milliseconds cause the movement at 500? Or does the unconscious readiness potential at time 0 cause both the conscious intention and the movement? And Libet's data suggests the latter, suggests that unconscious brain activity is the real cause, is the initiator, and conscious intention is just another effect, another consequence of the unconscious process. And if this is right, then conscious will is causally inert, does not actually produce behavior, is epiphenomenal. Many philosophers and scientists have challenged Libet's interpretation. One response questions the measurement of conscious intention, argues that asking subjects to note when they became aware of intending is asking them to introspect a process that might not be accessible to introspection, and the reported time of intention might be inaccurate, might be systematically delayed, and subjects might become aware of intending earlier than they report, perhaps at the same time as the readiness potential begins. And if conscious awareness actually coincides with the readiness potential, then there is no paradox. Consciousness is part of the initiating process, not an afterthought. Another response distinguishes between different kinds of decisions, argues that Libet's experiments involve arbitrary decisions, spontaneous movements without specific goals or reasons, and these are not typical of the kinds of decisions we care about when discussing free will. And meaningful choices, choices based on deliberation and reasons, might involve different neural processes, might involve consciousness more centrally. And Libet's findings about arbitrary wrist flexions do not generalize to all decisions, do not show that conscious deliberation is always epiphenomenal, and free will might be preserved for rational choices even if spontaneous impulses are unconsciously initiated. A third response questions the interpretation of the readiness potential, argues that early neural activity does not necessarily represent a decision or commitment to act, but might represent preparation, might be part of the process of forming an intention rather than being the cause of intention, and consciousness might be involved throughout this process. And the readiness potential and conscious intention might be parts of a single, integrated process rather than separate causes. And Libet's interpretation assumes too sharp a separation between unconscious and conscious processes, treats them as competing causes when they might be cooperative aspects of a single decision-making system. Some philosophers embrace Libet's findings, argue that they confirm what we should have known all along, that consciousness does not have magical causal powers, that all mental processes are brain processes, and brain processes are physical processes that operate according to causal laws, and conscious states are aspects of brain states, not separate entities that somehow reach into the physical world to cause behavior. And Libet's experiments help dispel the Cartesian illusion that consciousness is a separate substance with independent causal power, help show that we are physical beings whose actions are caused by physical brain processes, and consciousness is part of this physical system, not a separate controller. Libet himself proposed that consciousness might not initiate actions, but might have a veto power, might be able to stop actions that unconscious processes have initiated, and he found some evidence for this, found that conscious intention could inhibit movements, even after the readiness potential had begun, and this veto function preserves a role for conscious will, makes consciousness a gatekeeper if not an initiator, and this preserves some form of free will, free won't rather than free will, the ability to consciously inhibit unconsciously initiated impulses. The experiments have been repeated and refined by many researchers with various results, some confirming Libet's findings and others qualifying them, showing that the relationship between brain activity, conscious awareness, and action is more complex than Libet's original interpretation suggested, and the debate continues with no consensus about what the experiments show about free will, about whether they undermine it or are compatible with it. And the paradox persists as a live issue in neuroscience and philosophy. The subject flexes their wrist, notes the time of intention, and the electrodes record the readiness potential, and the timing reveals that brain activity preceded awareness. And the question remains what this means for free will, whether it shows that consciousness is epiphenomenal, that we do not truly initiate our actions, or whether the interpretation is wrong, whether consciousness is involved earlier than subjects report, or whether the experiments test the wrong kinds of decisions. And Libet's paradox endures as one of the most discussed and controversial findings in the neuroscience of volition, a set of experiments that appears to show that free will is an illusion, that our conscious sense of agency is a feeling that arises after decisions have already been made, and whether this appearance is accurate, whether the paradox is real or illusory, remains one of the most important questions at the intersection of neuroscience and philosophy. And the readiness potential builds, and consciousness awakens, and action follows, and the temporal order creates the paradox, and the debate continues. Locke's sock paradox. John Locke, the 17th century philosopher, offered a thought experiment about identity and change that has come to be known as Locke's sock paradox, though Locke himself discussed it in the context of broader questions about personal identity and the persistence of objects over time. And the paradox concerns a sock, or in some versions a shoe or a shirt, that is gradually repaired over years until every part of the original has been replaced. And the question arises whether it is still the same sock or whether it has become a different sock. And if it is different, then when did the transformation occur? And this puzzle is closely related to the ship of Theseus, but focuses on everyday objects and the intuitions we have about artifacts, possessions, and the things we use and care about in ordinary life. Imagine a sock that develops a hole, and the hole is darned with new thread. And later, another hole appears and is also repaired, and over time the entire sock is patched and repatched, thread by thread, until none of the original material remains. And yet throughout this process the sock has been continuously in use, worn by the same person, stored in the same drawer, and at no point was there a moment when someone discarded one sock and acquired a completely new one. And so there is a strong intuition that it is still the same sock. That identity has been preserved through gradual change. That continuity of use and function matter more than continuity of material. But now consider a variation. Suppose that each time the sock is repaired, the removed material is carefully saved, and eventually someone uses all the original threads to reconstruct a sock, weaving them back together into the original pattern. And now there are two socks, one that has been continuously worn and repaired, containing none of the original material, and one that has been reconstructed from the original material, but which has not been continuously used. And which of these is the original sock? Or are both originals? Or is neither? And different intuitions pull in different directions. Some say the continuously worn sock is the original because it has never ceased to exist, because there is an unbroken chain of identity linking it to the sock that was first worn years ago, while others say the reconstructed sock is the original because it's made of the original material, because material composition is what individuates objects. And still others say that both have some claim to being the original, or that the question has no determinate answer because identity is vague or conventional. Locke used examples like this to explore the conditions of identity over time, arguing that different kinds of things have different criteria for persistence, that a mass of matter is the same mass if it has the same constituent parts, but an artifact like a sock is the same sock if it has the same functional organization, and a living organism is the same organism if it has continuity of life, and a person is the same person if they have continuity of consciousness and memory. And so identity is not a single uniform relation, but varies depending on what kind of thing is in question. The sock paradox raises questions about artifacts and their relationship to their materials, because unlike natural objects, artifacts are defined partly by their functions and purposes. A sock is not just any piece of fabric, but a piece of fabric designed and shaped to be worn on a foot. And so perhaps what makes a sock the same sock over time is not the persistence of the same material, but the persistence of the same functional structure, the same ability to serve the purpose for which it was made. And if this is right, then the continuously repaired sock remains the original, even after all its material has been replaced, while the reconstructed sock, though made of original material, is a replica rather than the original because it lacks the continuity of function and use. But this view faces difficulties too, because it seems to make identity depend on extrinsic factors, on how the sock is used and perceived, rather than on intrinsic properties. And it raises the question of whether an artifact that is stored away unused for years ceases to be the same artifact, or whether a sock that is repaired and then used for a completely different purpose, say as a hand puppet, remains the same sock or becomes something else. The paradox also connects to questions about personal attachment and sentimental value, because people often care about particular objects, not merely because of their function, but because of their history, because of the associations and memories attached to them. And so a sock that has been worn for decades may have sentimental value that a newly reconstructed sock, even if materially identical, would not have. And this suggests that identity, at least in the context of personal possessions, is partly constituted by historical and relational properties, by the role the object has played in someone's life. And this relational view of identity implies that the continuously worn sock is the original because it has the right kind of historical connection to the person who owns it, while the reconstructed sock is a mere duplicate, physically similar, but lacking the history that gives the original its significance. The sock paradox also raises issues about vagueness and borderline cases because, in practice, the transition from original to replica is not sharp. There is no precise moment when the repaired sock stops being the original and becomes something else. And so perhaps the question of whether it is the same sock admits of no determinate answer. In borderline cases, perhaps identity is vague and the law of excluded middle. The principle that for any proposition, either it or its negation is true, fails for identity statements involving gradual change. The paradox has legal and practical implications as well. In contexts where the identity of an object matters for property rights warranties, insurance claims, or historical authentication. Courts and experts must sometimes decide whether a heavily restored painting or a rebuilt car is the same object as the original or a different object. And these decisions depend on criteria that are often contested, on judgments about how much change an object can undergo while remaining itself. And these judgments reveal that identity is not always a purely factual matter, but involves normative and pragmatic considerations, decisions about what we care about and what purposes our identity judgments are meant to serve. Lockie's sock sits in the drawer, worn and repaired, a humble object that embodies deep philosophical questions, and it reminds us that persistence through time is not as straightforward as common sense suggests, that the boundaries of objects are not fixed by nature, but negotiated through concepts and practices. That identity is a nexus of material, functional, historical, and relational factors, and that the question of whether something is the same thing it was before is often a question without a single correct answer, a question that depends on context, on what aspects of similarity and continuity we privilege, and on whether we are asking about material identity, functional identity, or historical identity. And the sock, like the ship of Theseus, sails on through philosophical discussion, a paradox that will not be mended, a puzzle that remains even after all its threads have been replaced. Newcomb's paradox, a being with perfect or near-perfect predictive abilities, presents you with two boxes, one transparent and one opaque. And the rules of the game are simple, but the decision is agonizing. And this is Newcomb's paradox, a thought experiment devised by physicist William Newcomb and popularized by philosopher Robert Nozick that has divided decision theorists and philosophers into rival camps for decades. The transparent box contains $1,000, visible and certain, while the opaque box contains either $1 million or nothing, and the amount depends on a prediction made by the being before you arrived. If the being predicted you would take only the opaque box, then it placed $1 million inside. But if it predicted you would take both boxes, then it left the opaque box empty. The being has made this offer to many people before and has never been wrong. Its predictions are accurate with such consistency that it seems to know the future, or at least to understand human psychology so deeply that it can foresee choices with near certainty. Now you must decide, do you take only the opaque box, trusting the prediction and hoping for $1 million? Or do you take both boxes, reasoning that whatever is in the opaque box is already determined, and you might as well collect the extra $1,000 from the transparent box? The paradox arises because two different principles of rational decision-making give opposite answers, and both seem compelling. The expected utility calculation favors taking only the opaque box, because if the being is almost always right, then taking only the opaque box gives you a high probability of receiving $1 million, while taking both boxes gives you a high probability of receiving only $1,000. And so the one-box strategy maximizes expected value. But the dominance principle suggests taking both boxes, because at the moment you make your choice, the contents of the boxes are already fixed. The being has already made its prediction and either placed the $1 million or not. And since the past cannot be changed, your decision cannot affect what is in the opaque box. And therefore, taking both boxes gives you $1,000 more than taking only the opaque box. No matter what the opaque box contains, and dominance reasoning says you should always choose the option that does better in every possible state of the world. The paradox forces a choice between two deeply held intuitions about rationality: the idea that rational agents should maximize expected utility, and the idea that rational agents should not leave money on the table when doing so cannot possibly make things worse. Philosophers and decision theorists remain divided. Some are one-boxers who argue that the being's predictive accuracy makes the dominance reasoning irrelevant, that the correlation between your choice and the contents of the box is so strong that you should act as if your decision causally affects the prediction, even though temporally it does not. While others are two boxers who insist that causal reasoning demands taking both boxes, that the prediction is already made and your choice now cannot retroactively change it, and that one boxers are falling prey to magical thinking, confusing correlation with causation. The paradox also touches on issues of free will and determinism, because if the being can predict your choice with perfect accuracy, then in what sense is the choice free? And if the choice is not free, then what does it mean to deliberate about it? And if determinism is true, does that undermine the concept of rational decision-making altogether? Newcomb's paradox has inspired the development of new decision theories, including causal decision theory, which endorses two boxing, and evidential decision theory, which endorses one boxing, as well as more exotic approaches like timeless decision theory and functional decision theory, which attempt to handle cases where agents can predict or simulate each other. The paradox remains unresolved, a strange meeting point of probability, causation, choice, and prediction, a puzzle that reveals how little we understand about what it means to decide, and whether the principles we use to navigate an uncertain world are as solid as we believe, or whether they crumble when pressed against beings who can see through us, who know what we will do before we do it, who turn decision-making into a game where the rules themselves are in question. Nagel's bat problem: why you can never know what it's like to be anything else. A philosopher contemplates a bat hanging upside down in a cave, navigating through echolocation, emitting high-frequency sounds and listening to the echoes, building a sonic map of the world. And the philosopher asks what it is like to be a bat. What is the subjective character of bat experience? What does echolocation feel like from the inside? And philosopher Thomas Nagel argues that no amount of objective information about bat neuroscience, about bat behavior, about the physics of sonar, can tell us what bat experience is like, because subjective experience has an essential first-person character, a what-it-is likeness that cannot be captured from the third-person objective perspective of science, and the gap between objective description and subjective experience is unbridgeable. And this means that consciousness, at least in its subjective aspect, resists scientific explanation, resists reduction to physical terms. And this is Nagel's bat problem, presented in his famous 1974 paper, What Is It Like to Be a Bat? And the problem illustrates the explanatory gap between physical facts and phenomenal facts, shows that subjective experience involves something that objective science cannot capture, and challenges physicalist theories of mind to explain how subjective character could be accommodated within a purely physical framework. Imagine trying to know what echolocation is like, trying to understand bat experience from the inside, and you learn all the objective facts, learn about the bat's auditory system, about how it processes echoes, about which brain regions are involved. And this knowledge is real, is valuable, tells you how echolocation works, but it does not tell you what it feels like, does not give you access to the bat's subjective experience, to the phenomenology of navigating by sound. And Nagel's point is that this gap is not due to practical limitations, not due to insufficient technology or incomplete knowledge, but is a fundamental gap between objective and subjective perspectives, between what can be known from outside and what can only be known from inside. And no amount of objective knowledge can bridge this gap, can provide access to subjective experience. The bat problem generalizes beyond bats to any creature with a different sensory modality, a different nervous system, a different form of consciousness. And Nagel uses bats because they are mammals, are relatively similar to humans, yet have a sensory mode, echolocation, that humans lack. And this combination makes the example vivid, makes the gap between human and bat experience clear. And if we cannot know what it is like to be a bat, then we certainly cannot know what it is like to be a fish, an insect, an octopus, creatures whose nervous systems and sensory worlds are even more alien. And this suggests that consciousness, in its subjective aspect, is fundamentally private, is accessible only to the being who has it, and different kinds of consciousness are mutually inaccessible, cannot be fully understood from outside. Visualize the subjective character of experience as the view from inside, the first-person perspective, the what it is likeness. And this perspective is essential to consciousness, is what makes consciousness consciousness rather than merely information processing. And Nagel argues that physicalism, the view that everything is physical, must either deny that subjective character exists, which seems false because we all know from our own case that consciousness has a subjective character, or must explain how subjective character could be physical, how objective physical facts could constitute subjective, first-person experiences. And this explanation is what physicalism has not provided, what the bat problem challenges physicalism to provide. One response to the bat problem accepts the explanatory gap, but denies that it shows anything metaphysical, argues that the gap is merely epistemological, is about the limits of what we can know rather than about the nature of reality, and consciousness might be physical, even though we cannot fully understand it from the objective third-person perspective. And just as we cannot know what it is like to be a bat, we also cannot know what it is like to be another human, cannot fully access their subjective experiences, and yet we do not conclude that human consciousness is non-physical. And so the bat problem shows limits of knowledge, but not limits of physicalism, shows that subjective experience has aspects that resist objective description, but not that these aspects are non-physical. Another response argues that future science might bridge the gap, might develop ways of understanding subjective character objectively, might create theories that capture phenomenology in physical terms, and our current inability to imagine how this could be done does not prove that it cannot be done. And Nagel's argument trades on current ignorance, assumes that the gap is permanent when it might be merely temporary, and this response is optimistic about the prospects for physicalist explanations of consciousness, believes that the hard problem and the bat problem will eventually be solved by scientific progress. A third response from Nagel's position argues that the bat problem reveals something deep about the structure of reality, that consciousness has an irreducibly subjective aspect, an aspect that cannot be captured by objective physical description. And this does not mean consciousness is non-physical in the sense of being immaterial or supernatural, but it means that physicalism, as traditionally conceived, is incomplete, misses something essential about consciousness, and a complete theory of reality must include both objective physical facts and subjective phenomenal facts. And these two kinds of facts cannot be reduced to each other. And this position is sometimes called naturalistic dualism, accepts that consciousness is natural, is part of the natural world, but denies that it is reducible to physics. The bat problem also has implications for artificial intelligence, for whether machines could be conscious, because if we cannot know what it is like to be a bat, then we also cannot know what it is like to be a computer, cannot know whether AI systems have subjective experiences, and the bat problem suggests that behavioral evidence is insufficient, that even if a machine passes every behavioral test, exhibits intelligence, responds appropriately to stimuli, we still cannot know whether there is something it is like to be that machine, whether there is subjective experience behind the behavior, and this creates a permanent epistemic barrier, a limit on what we can know about machine consciousness. The bat hangs in the cave, emitting sounds, perceiving the world through echoes, and its experience is alien, is inaccessible to human understanding. And Nagel's question remains, what is it like? And the answer is we do not know, cannot know, because knowing requires access to the subjective perspective, requires being the bat or having the bat's sensory and cognitive capacities, and neither is possible. And so bat consciousness remains a mystery, remains forever beyond human comprehension. And this mystery is not unique to bats but applies to all consciousness, to the fundamental subjectivity of experience, to the what it is likeness that defines phenomenal consciousness, and Nagel's bat problem endures as one of the most influential thought experiments in philosophy of mind. A vivid illustration of the explanatory gap, a challenge to physicalist theories, and a reminder that consciousness, in its subjective aspect, resists objective description, resists scientific reduction, and remains one of the deepest puzzles about the nature of mind and reality. And the bat flies through the cave, navigating by sound, living its bat life, having its bat experiences, and what those experiences are like remains unknown, remains unknowable. And the problem persists, the gap between objective knowledge and subjective experience, the difference between knowing about consciousness and knowing consciousness from the inside. And Nagel's question echoes, what is it like to be a bat? And no answer comes, no answer can come, and the problem stands as a permanent marker of the limits of objective understanding, the irreducible subjectivity of experience and the mystery at the heart of consciousness. Moore's open question, argument why good cannot be defined. A philosopher claims to have defined goodness, claims that good means pleasure, or good means what evolution favoured, or good means what most people approve of, and the definition is offered with confidence, with arguments and evidence supporting it, and yet G.E. Moore, in his 1903 book Principia Ethica, pointed out a fatal problem with all such definitions, a problem so simple and devastating that it has shaped ethics ever since. And the problem is this: take any proposed definition of good, any equation of goodness, with some natural property, and you can always ask a meaningful question. You can ask, but is that property itself good? And the fact that this question remains open, remains intelligible, and not obviously silly, shows that the definition has failed, shows that good has not been captured by the natural property. And this is Moore's open question argument, a challenge to naturalistic definitions of good that attempts to prove that goodness is indefinable, that it cannot be reduced to any natural fact or property, that it is a simple, unanalysable concept that we grasp directly through moral intuition but cannot explain in other terms. Imagine someone says good means pleasant, pleasure is what good is, and now Moore asks the open question, but is pleasure good? And this question makes sense, is not absurd, is not like asking whether bachelors are unmarried men, where the question is trivially answered by the definition. And the fact that we can meaningfully ask whether pleasure is good shows that good does not mean the same thing as pleasant. Otherwise, the question would be equivalent to asking whether pleasant things are pleasant, which is a meaningless tautology. And since the question is not meaningless, since we can intelligently disagree about whether pleasure is good, the definition must be wrong, must have failed to capture what goodness really is. The same argument applies to any naturalistic definition. If someone says good means evolutionarily advantageous, we can ask, but is what evolution favoured good? And this is an open question. Many people would say no, that evolution produces traits that help survival and reproduction, but not necessarily traits that are morally good, that rape and infanticide might be evolutionarily advantageous in some contexts, but are not good, and so the definition fails. Or if someone says good means desired by most people, we can ask, but is what most people desire good? And again, this is open. We can imagine societies where most people desire things that are actually bad, where popular opinion is mistaken, and so the definition fails again. Moore concluded that good is indefinable, not because we do not know what it is, but because it is a simple, primitive concept, like yellow or existence, something that cannot be broken down into simpler parts or explained in other terms, but must be grasped directly. And we know good through moral intuition, through a kind of perception that is not sensory but intellectual. And different people's intuitions might disagree, but that does not mean goodness is subjective. It might mean that some people perceive moral reality more clearly than others, just as some people have better colour vision, and Moore's position is a form of non-naturalism, the view that moral properties are real but not natural, not part of the physical world studied by science, but a distinct realm of normative facts that exist objectively. The open question argument has generated enormous controversy. Critics argue that it proves too much, that the same reasoning would show that nothing can be defined, because for any definition, we can ask an open question. If water is H2O, we can ask, but is H2O water? And before we learned the chemistry, this question was open. People could meaningfully disagree, and yet we now accept that water is H2O as a correct identity. Not a definition of meaning, but an empirical discovery about what water turns out to be. And perhaps good is like this. Perhaps good is identical to some natural property, not as a matter of meaning, but as an empirical fact about what goodness turns out to be. And the open question shows only that we have not yet discovered which natural property good is, not that no such property exists. Others argue that the open question argument assumes too much about how meaning works, assumes that if two terms mean the same thing, then they must be obviously synonymous. But this is false. Morning star and evening star both refer to Venus, but it was not obvious. People could meaningfully ask whether the morning star is the evening star. And so Moore's test fails. The fact that a question is open does not prove that the terms do not refer to the same thing. And so the open question argument does not establish that good is indefinable, only that the definition is not obvious, not transparent. And this leaves room for naturalistic theories that identify goodness with some natural property as an empirical discovery rather than a conceptual analysis. Visualize Moore's argument as a test applied to proposed definitions. Each definition is presented, good equals X, and Moore applies the test. He asks, is X good? And if the question is intelligible, if it makes sense to ask, if competent speakers can understand the question and disagree about the answer, then the definition fails. X does not capture what good means. And Moore applies this test to definition after definition. Hedonism says good equals pleasure. Moore asks, is pleasure good? The question makes sense. Test failed. Naturalism says good equals natural property. Why? Moore asks, is Y good? The question makes sense. Test failed. And the test seems to show that no natural property can be identical to goodness. That good resists reduction, resists naturalization, stands apart from the world of facts, and refers to something normative, something that cannot be captured by descriptive language. The argument has implications for metaethics, for the question of what kind of thing goodness is. If Moore is right, then moral realism, the view that moral facts exist objectively, must be non-naturalist, must accept that moral properties are sui generis, distinct from natural properties, irreducible to physics or biology or psychology. And this raises questions about how we can know moral facts, how moral properties relate to natural properties, whether moral facts can cause anything or play any role in explaining behaviour. And non-naturalism faces challenges, struggles to explain how we perceive non-natural properties, how they fit into a scientific worldview, whether they're compatible with naturalism about everything else. The open question argument also influenced emotivism and expressivism, non-cognitivist views that deny moral statements are factual claims at all, argue instead that moral language expresses attitudes or emotions rather than describing reality, and these views claim to explain why the open question is always open, because good does not refer to any property, natural or non-natural, but expresses approval or prescribes action. And so asking whether X is good is asking whether to approve of X, whether to pursue it. And this is always an open question, always something we can meaningfully deliberate about. But the non-cognitivists deny Moore's conclusion, deny that goodness is a real property we intuit, argue instead that moral language has a different function, is not in the business of describing reality, but of expressing commitments and guiding action. More's argument changed the landscape of ethics, forced philosophers to take seriously the question of whether moral properties are natural or non-natural, whether moral knowledge is empirical or a priori, whether ethics can be reduced to science or remains a distinct domain, and the argument remains controversial. Some see it as a decisive refutation of naturalism. Others see it as a confusion about meaning and reference. And the debate continues, with naturalists proposing sophisticated identities between moral and natural properties, with non-naturalists defending irreducible normativity, and with non-cognitivists denying that moral language describes properties at all. And More's open question sits at the centre of these disputes, a simple test that reveals deep issues about meaning, about value, about the relationship between facts and norms, and about whether goodness is something we discover in the world or something we project onto it. And the question remains open, always open, because that is what good does. It resists definition, resists reduction, remains stubbornly normative, always inviting the question, but is that really good? And no answer closes the question, no definition settles it. And More's argument endures as a reminder that ethics is not reducible to any other domain, that the normative cannot be fully naturalized, and that goodness, whatever it is, stands apart, indefinable, and irreducible, a primitive concept that we use, but cannot explain. Meinong's paradox, where non-existent objects live. A philosopher named Alexius Meinong proposes a strange theory, a theory about objects that do not exist, and Meinong argues that there are objects that do not exist, but still have properties, can be talked about, can be thought about, and these non-existent objects populate what Meinong calls the realm of being, a broader category than existence, and examples include the Golden Mountain, which does not exist but is golden and is a mountain, and the round square, which does not exist but is round and square, and Sherlock Holmes, who does not exist but is a detective and lives on Baker Street. And Meinong's theory says we can make true statements about these non-existent objects, can say truly that the Golden Mountain is golden, even though no Golden Mountain exists. And this creates paradoxes, creates puzzles about the nature of reference and truth. Because how can statements about nothing be true? How can non-existent objects have properties? How can we refer to what does not exist? And this is Meinong's paradox, the puzzle about non-existent objects, about whether they are real in some sense, whether being is broader than existence, whether there are things that do not exist but still have some kind of reality. And this paradox has generated enormous discussion, has led some philosophers to defend Meinong's theory in modified form and others to reject it entirely, to argue that non-existent objects are impossible, are contradictions, and all objects that can be thought about must exist in some sense. Imagine thinking about Sherlock Holmes, picturing the detective, his deerstalker hat, his pipe, his address at 221B Baker Street, and you're thinking about something. Your thoughts have content, have an object, and that object is Sherlock Holmes. But Sherlock Holmes does not exist, was never a real person, is a fictional character invented by Arthur Conan Doyle. And so, what are you thinking about when you think about Sherlock Holmes? What is the object of your thought? And Meinong says the object is Sherlock Holmes himself, a non-existent object, an object that has properties like being a detective and living on Baker Street but lacks the property of existence. And this seems to make sense of how we can think about fictional characters, how we can make true statements about them, but it creates problems because it seems to commit us to a vast ontology of non-existent objects. All the fictional characters, all the impossible objects like round squares, all the merely possible objects that could exist but do not. And this ontology seems bloated, seems to violate parsimony, seems to multiply entities beyond necessity. The paradox sharpens when we consider impossible objects, objects like the round square, which is both round and square, and these properties are incompatible, cannot both be instantiated by a single object. And yet Meinong's theory seems to allow that the round square is both round and square, has both properties despite their incompatibility, and this violates the law of non-contradiction, seems to allow contradictions to be true. And Russell famously criticised Meinong for this, argued that the round square both exists and does not exist. Exists because it has properties and things with properties must exist to have them, and does not exist because that is part of its characterization. And this contradiction shows that Meinong's theory is incoherent, cannot be accepted, and non-existent objects are impossible, and all talk of them must be reinterpreted as talk of something else, talk of ideas or words or possible worlds, but not talk of actual non-existent objects. Visualize Meinong's ontology as having two realms: the realm of existence containing actual objects, like tables and mountains and people, and the realm of being containing all objects, including non-existent ones like golden mountains and fictional characters. And the realm of being is vastly larger, contains everything we can conceive, all possibilities and impossibilities, and only a tiny subset of being also has existence. And Meinong's theory says that statements can be true of objects in the realm of being whether or not those objects exist, and truth is not restricted to existing objects. And this solves certain puzzles about reference, about how we can refer to what does not exist, but creates the paradox of how non-existent objects can have properties, can be subjects of true predications when there is nothing there to have the properties. One response to Meinong's paradox rejects non-existent objects, adopts Russell's theory of descriptions, which analyzes statements about non-existent objects as existential statements that happen to be false, and the golden mountain is golden becomes. There exists something that is golden and is a mountain, and this statement is false because no such thing exists. And fictional statements are understood as prefixed by an implicit fiction operator. In the Sherlock Holmes stories, it is true that Holmes is a detective, and this preserves the intuition that Holmes is a detective, in some sense, while avoiding commitment to non-existent objects. And this Russellian approach has been standard in analytic philosophy, is the orthodox view, treats apparent reference to non-existent objects as disguised quantification or as occurring within the scope of intentional operators. Another response defends Meinong's theory in modified form, accepts that there are non-existent objects, but restricts what properties they can have, distinguishes between nuclear properties like being golden or being a detective, which non-existent objects can have, and extra-nuclear properties like existing or being thought about, which are different, and impossible objects like round squares have both roundness and squareness as nuclear properties, but do not violate contradiction because they do not exist, do not have instances in reality, and their properties do not need to be jointly instantiable. And this neo-Meinongian approach preserves some of Meinong's insights while avoiding Russell's objection, and various philosophers, including Terence Parsons and Richard Routley, have developed sophisticated neo-Meinongian theories that handle the paradoxes. A third response appeals to possible worlds, argues that fictional and non-existent objects exist in other possible worlds, are possible but not actual, and when we talk about Sherlock Holmes, we're talking about a possible person, someone who exists in other possible worlds, in worlds where Conan Doyle's stories are true, and this preserves the intuition that Holmes is a detective, is a real object in some sense, while avoiding the paradox of non-existent objects, because Holmes is not non-existent but merely non-actual, exists in other worlds. And possible worlds semantics provides a framework for understanding modality and fiction without Meinongian ontology. Meinong's paradox also raises questions about what it means to exist, about whether existence is a property like others or is somehow special, and Kant argued that existence is not a real predicate, not a property that objects have or lack, but is the presupposition of having properties. And this Kantian view seems to refute Meinong, seems to show that non-existent objects cannot have properties because having properties requires existing. But Meinongians respond that this assumes existence is necessary for predication, that only existing things can have properties, and this assumption is precisely what Meinong denies. And the debate continues about whether existence is a property and whether objects must exist to have properties. The golden mountain glitters in imagination, non-existent but golden, and Sherlock Holmes solves cases in fiction, non-existent but a detective, and the round square defies logic, non-existent and impossible, and Meinong's theory says these are real objects in the broad sense of being, and the paradox asks how this can be, how nothing can be something, how non-existence can have properties, and the answers divide philosophers, some accepting Meinong's insights, some rejecting them entirely, and the paradox persists as a challenge to theories of reference and ontology, a puzzle about what we talk about when we talk about what does not exist, and whether such talk requires real objects or can be explained without them. And Meinong's paradox endures as one of the strangest and most controversial problems in metaphysics, a problem about the boundary between being and non-being, about what counts as real, and about whether existence is the only kind of reality or whether non-existent objects have their own shadowy realm of being. Quine's Gavagai problem? Why we can never know what anyone really means. An anthropologist arrives in a remote village to study an unknown language, a language no outsider has encountered before. And the anthropologist has no translator, no dictionary, no common linguistic framework, only observations and patience, and the method is radical translation. Learning the language from scratch by observing how natives use words in response to events. And one day, a rabbit runs past and a native points and says Gavagai, and the anthropologist writes in the notebook, Gavagai means rabbit. And this seems reasonable, seems like an obvious inference. The native saw a rabbit and said Gavagai, so Gavagai must refer to rabbits. But philosopher Willard Van Orman Quine points out a problem, a deep problem about meaning and translation. Because Gavagai might mean rabbit, but it might also mean undetached rabbit part, or rabbit stage, or collection of rabbit molecules, or instance of rabbithood. And all these translations are consistent with the native's behaviour. All would lead the native to say Gavagai in exactly the same circumstances, whenever a rabbit is present, and there is no fact of the matter, no objective truth about which translation is correct, no way to determine what Gavagai really means. And this indeterminacy is not due to practical limitations, not due to insufficient evidence, but is fundamental, is a consequence of how meaning works. And this is Quine's Gavagai problem, also called the problem of indeterminacy of translation, a challenge to the idea that words have determinate meanings, that translation has right answers, and that we can know what others mean when they speak. Imagine trying to distinguish between Gavagai means rabbit and Gavagai means undetached rabbit part. And you point to the rabbit and the native says Gavagai, and you point to the rabbit's ear and ask whether this is Gavagai, and the native responds, but you do not know whether the response means yes because the ear is an undetached rabbit part, or no, because the ear is not a whole rabbit, or something else entirely. And every test you design, every question you ask, can be interpreted in multiple ways, can be answered consistently by multiple translations, and no amount of observation, no behavioural evidence can definitively settle which translation is correct, because the native's behaviour under all possible circumstances is compatible with multiple interpretations. And Quine argues that this shows meaning is indeterminate, that there is no fact about what Gavagai really means, only different translation manuals that work equally well, that map the native's language onto ours in different but equally legitimate ways. The problem generalizes beyond anthropology to all understanding of language, because even when we share a language, even when we both speak English, the Gavagai problem applies. We cannot be certain that we mean the same thing by our words, that rabbit means to you what it means to me. We might be using different concepts, carved up differently, but our behaviour is similar enough that we never notice the difference. And this raises the disturbing possibility that communication is always partial, always approximate, that we never fully understand each other, that meaning is not something objective that words have, but something we impose through interpretation. And different interpretations can fit the evidence equally well, and there is no transcendent perspective from which to judge which interpretation is correct. Visualize meaning as a relationship between words and world, and Quine's point is that this relationship is underdetermined by behaviour, by the evidence available to translators, because infinitely many relationships are consistent with the same behavioural evidence. Infinitely many ways of mapping words to world produce the same observable patterns, and choosing among these possibilities requires going beyond evidence, requires making decisions that are not forced by facts, and these decisions constitute meaning rather than discovering it. And so meaning is partially conventional, partially stipulated, not fully determined by reality. The Gavagai problem challenges referential theories of meaning, theories that say words mean things because they refer to objects in the world, because rabbit refers to rabbits, and water refers to water, and Quine's argument shows that reference is inscrutable, cannot be determined from behaviour alone, because words can be interpreted as referring to different things, different ways of carving up reality, and all interpretations fit the evidence, and so reference is not an objective relation, but is relative to a translation manual, relative to a scheme of interpretation, and different manuals. Different schemes can assign different references to the same words while remaining equally correct. One response to the Gavagai problem accepts the indeterminacy, embraces it as a truth about meaning, argues that Quine is right, that there is no fact of the matter about what words mean beyond what is determined by behavioural evidence, and meaning is holistic, depends on the entire network of beliefs and language practices. And translation manuals are theoretical frameworks that organise this evidence. And like all theories, they are underdetermined by data, and multiple theories fit the same data equally well. And choosing among them involves pragmatic considerations, simplicity, utility, coherence, but not truth in any absolute sense. And this response treats meaning as a human construction, something we create through practices rather than something we discover in nature. Another response denies the indeterminacy, argues that Quine's thought experiment is artificial, that in real translation situations additional evidence is available, evidence about intentions, about how speakers correct each other, about the structure of their conceptual schemes. And this additional evidence narrows down the possibilities, rules out bizarre interpretations like undetached rabbit part, and determines that Gavagai means rabbit in the ordinary sense. And while perfect certainty may be impossible, practical determinacy is achievable, and meaning is objective enough for communication to succeed, for translation to have right and wrong answers. And the Gavagai problem is an epistemological worry, a concern about how we know what words mean, but it does not show that words lack determinate meanings, only that discovering those meanings is difficult. A third response appeals to charity, to the principle that we should interpret speakers as making sense, as having coherent beliefs, as speaking truly most of the time. And this principle constrains translation, rules out interpretations that make speakers irrational or massively mistaken. And while charity does not uniquely determine translation, it narrows the range of acceptable interpretations, and combined with simplicity and other pragmatic virtues, it makes translation tractable, makes it possible to arrive at good translations, even if not perfect ones. And this response treats translation as an interpretive practice, guided by norms rather than as a purely empirical investigation, guided only by behaviour. The Gavagai problem also connects to broader philosophical issues about realism and anti-realism, about whether there are objective facts independent of our theories and languages, Because if meaning is indeterminate, then perhaps reality itself is indeterminate. Perhaps there is no fact about whether rabbits or undetached rabbit parts exist, only different ways of organizing experience, different conceptual schemes that carve up the world differently. And Quine's ontological relativity, his claim that what objects exist is relative to a language or theory, follows from the Gavagai problem, from the recognition that reference is inscrutable, that we cannot say what exists absolutely, but only what exists relative to a framework. The anthropologist sits with a notebook, the word Gavagai recorded, the translation uncertain, and the native speaks, and the anthropologist interprets, and communication proceeds approximately, pragmatically, successfully enough for practical purposes, and whether Gavagai really means rabbit or something else remains undetermined, remains a question without an answer, and Quine's problem persists, not as a practical obstacle to translation, but as a philosophical challenge to theories of meaning, as a demonstration that meaning is more elusive than we thought, more dependent on interpretation and less determined by facts. And the Gavagai problem endures as one of Quine's most influential contributions, a thought experiment that changed how philosophers think about language, about meaning, about translation, and about the relationship between words and world. And the problem remains unsolved, perhaps unsolvable, a permanent feature of linguistic philosophy, a reminder that understanding each other is harder than it seems, that meaning is indeterminate, that communication is an achievement rather than an automatic consequence of shared language, and that the gap between what we say and what we mean, between our words and their reference, can never be fully closed. And the rabbit runs past and the native says, Gavagai, and we translate approximately, hopefully, never quite certain that we have understood. Richard's paradox. In 1905, the French mathematician Jules Richard discovered a paradox that strikes at the heart of how language and mathematics interact, revealing that certain kinds of definitions can generate contradictions no matter how carefully they're constructed. Consider the set of all real numbers that can be defined in a finite number of words using the English language. And this set seems reasonable at first because most numbers we ever think about can be described in some way. Pi is the ratio of a circle's circumference to its diameter. The square root of 2 is the length of the diagonal of a unit square, and so on. Since there are only finitely many words in the English language and only finitely many ways to arrange them into sentences of any given length, there can only be countably many such descriptions, which means there are only countably many real numbers that can be defined in this way. Yet the real numbers are uncountable, as Georg Cantor proved, which means there must exist real numbers that cannot be defined in any finite number of English words. Numbers that are forever beyond the reach of language, numbers that exist but cannot be named or described or pointed to in any way. Now comes the paradox. Consider the real number defined as follows. Let it be the first real number in the set of all real numbers that cannot be defined in a finite number of English words, arranged in some standard ordering, such as numerical order. This definition appears to successfully define a specific real number, and the definition itself uses only a finite number of English words, which means the number it defines belongs to the set of numbers that can be defined in a finite number of words, but the definition explicitly states that the number belongs to the set of numbers that cannot be defined in a finite number of words, and so the contradiction emerges, sharp and unavoidable. If the number can be defined, then it does not belong to the set of undefinable numbers, but the definition picks it out precisely as a member of that set. And if it cannot be defined, then the definition fails to refer to anything at all, and yet the definition seems perfectly coherent, grammatically correct, and mathematically precise. Richard's paradox exposes a fundamental problem with the concept of definability, the idea that we can cleanly separate describable objects from indescribable ones, because the act of describing the indescribable creates a loop that collapses into contradiction. Some logicians argue that the phrase cannot be defined in a finite number of words, is itself vague or improperly formalized, that it mixes informal natural language with formal mathematical concepts in a way that generates confusion, and that a more rigorous treatment would prevent the paradox from arising. Others suggest that the paradox reveals a hierarchy in language, that definitions must be made within specific formal systems, and that talking about all possible definitions requires stepping outside the system into a meta-language, and that mixing these levels is where the contradiction appears. Alfred Tarski developed this idea into a full theory of truth and definability, showing that no language can fully express its own semantic concepts without risking paradox, that truth and definability must always be relativized to a particular formal system, and that higher order languages are needed to talk about lower order ones. Richard's paradox also influenced the development of computability theory, because the question of whether a number can be defined in a finite number of words is closely related to whether it can be computed by a finite algorithm, and paradoxes like Richard's helped clarify the distinction between computable and non-computable reals. The paradox remains a haunting reminder that language, even mathematical language, has limits, that not everything that exists can be captured in words, and that the boundary between the describable and the indescribable is not as stable as it first appears. Synesthesia. Paradox: why numbers have colours and sounds have tastes. A person looks at the number 5 and sees it as blue, not imagines it as blue, not associates it with blue, but actually sees blue, experiences colour as an intrinsic property of the number. And another person hears music and tastes chocolate, hears certain chords, and the taste appears involuntarily, automatically. And these experiences are synesthesia, are cross-modal sensory experiences where stimulation in one modality produces perception in another. And synesthesia is not metaphor, is not learned association, is a genuine perceptual phenomenon experienced by roughly 4% of the population. And the paradox is that synesthetes experience properties that are not physically present, see colours that are not in the stimulus, taste flavours that have no source, and yet these experiences are consistent, are reliable. The same numbers always evoke the same colours, the same sounds always evoke the same tastes, and this reliability distinguishes synesthesia from imagination or association, shows that synesthesia is automatic, is perceptual rather than cognitive, and the phenomenon reveals something fundamental about how the brain is organised, shows that sensory modalities are not strictly separate, but can communicate, can influence each other, and synesthesia represents an extreme of this cross-modal interaction, represents a neural architecture where connections between sensory areas are stronger than normal, are sufficient to produce conscious experiences in one modality when another is stimulated. Imagine being a grapheme colour synesthete, the most common form where letters and numbers evoke colours, and you read this text and every letter has its own colour. A is red, B is green, C is yellow, and the colours are vivid, are as clear as real colours, are not vague or imagined but are perceptually present. And when you see the letter A, you cannot help but see red. The colour is automatic, is triggered by the visual form of the letter, and this colouring happens for all letters and numbers, creates a richly coloured experience of reading. And while this might sound beautiful, it can also be distracting, can interfere with reading when the printed colours conflict with synesthetic colours, can create confusion, and yet for synesthetes, this is normal, is how the world has always looked. And they are often surprised to learn that others do not experience letters as coloured, that the colours are unique to synesthetes. Synesthesia demonstrates that perception is not modular, is not strictly segregated by sensory modality, and in synesthetes there is cross-activation, There are connections between sensory areas that do not exist or are weaker in non-synesthetes, and these connections allow activity in one area to trigger activity in another. And when grapheme area, the region that processes letter and number shapes, is activated, it also activates color area, the region that processes color, and this cross-activation produces the experience of colored letters. And neuroimaging studies have confirmed this, have shown that when synesthetes see numbers, color areas of visual cortex are activated, are lit up. And this activation is automatic, is bottom-up, is not produced by conscious thought or imagination, but is triggered by the stimulus itself. Visualize the brain as having sensory areas that are normally separate: visual area, auditory area, taste area, and these areas process their respective inputs and pass information to higher level regions. But in synesthetes, there are additional connections. There are pathways between sensory areas that allow direct crosstalk, and these pathways are the neural basis of synesthesia, are what allows stimulation in one modality to produce experiences in another. And the connections are not learned, are not created through experience, but are developmental, are present from early life. And synesthesia is lifelong, is consistent. The same cross-modal experiences occurring throughout the synesthete's life. The synesthesia paradox is that these experiences are perceptual, are as real as any other perception, and yet the properties perceived are not present in the stimulus. The number 5 is not blue, is black on white, and yet the synesthete sees blue. And this challenges theories that say perception is veridical, is accurate, is a representation of physical reality. And synesthesia shows that perception can include properties that are not in the world, that are generated internally, and yet these properties feel external, feel like properties of objects rather than like internal mental states. And this raises questions about the nature of perception, about what it means for perception to be of something, about whether all perception involves some degree of construction, some degree of adding properties that are not in the stimulus. One theory of synesthesia is that everyone is born with extensive cross-modal connections, that infant brains have connections between all sensory areas, and during development, most of these connections are pruned or eliminated, and sensory areas become more segregated. And in synesthetes, some of these early connections are preserved, are not pruned, and this preservation allows the cross-modal experiences to continue into adulthood. And this theory is supported by evidence that infants show some synesthetic effects, show cross-modal correspondences, and that synesthesia runs in families, has a genetic component, suggesting that genes that regulate synaptic pruning are involved. Another theory is that synesthesia involves disinhibition, involves normally present connections between sensory areas that are usually inhibited, are suppressed, and in synesthetes this inhibition is weakened, is less effective, and so the connections are active, allow cross-activation, and this theory is supported by evidence that synesthesia can be induced temporarily in non-synesthetes through drugs that reduce inhibition, through hypnosis, through sensory deprivation, suggesting that the neural machinery for synesthesia is present in everyone, but is normally inhibited, and synesthetes have less inhibition, have more open channels between sensory areas. Synesthesia also has practical implications. Some synesthetes report that their experiences are useful, provide memory aids, make information more distinctive, easier to remember, and some musicians with sound colour synesthesia report that the colours help with composition, with understanding musical structure, and some artists deliberately cultivate synesthetic experiences, use them as sources of creativity. And understanding synesthesia has implications for education, for recognizing that people process information differently, that sensory experiences vary across individuals, and that teaching should accommodate these differences, should recognize that some students have richly colored experiences of letters and numbers, while others do not. The phenomenon also raises questions about consciousness, about qualia, about the subjective properties of experience, because synesthetes have different qualia than non-synesthetes, have colour experiences that others do not, and this shows that consciousness is not uniform, is not the same across individuals, and qualia vary, and this variation is not just quantitative, is not just more or less of the same experience, but is qualitative, involves entirely different types of experience, and this challenges theories that say, well, consciousness is universal, is the same for everyone, and supports theories that say consciousness is individual, is constructed by each brain in potentially different ways. And synesthesia is one example of this variation, is one way that consciousness can differ. Some philosophers argue that synesthesia shows that perception is not representational, does not represent external properties, because the colours seen by graphema colour synesthetes do not represent anything in the world. The number 5 is not blue, and yet the colour is perceived, and this challenges representational theories of perception, suggests that perceptual experiences are not always representations of external properties but can be internally generated responses. And synesthesia is a case where the response includes properties that are not being represented, and this raises questions about what makes perception representational, whether all aspects of perception are representations or whether some are merely responses are produced by the perceptual system without representing anything external. The number appears black on white, and the synesthete sees blue, vivid and automatic. The colour is as real as the number, is as perceptually present, and yet the colour is not there, is not in the stimulus, is generated by the brain, is a cross-modal activation, and the synesthesia paradox remains: perception includes non-veridical properties, includes experiences that do not correspond to stimulus properties, and yet these experiences are automatic, are reliable, are as perceptually real as any other, and synesthesia endures as one of the most fascinating phenomena in neuroscience, a demonstration that sensory modalities are not strictly separate, that cross-modal connections exist, that perception can include internally generated properties, and that consciousness varies across individuals, includes experiences that are unique, that are not shared by everyone, and the colours remain overlaid on letters, triggered by sounds, evoked by tastes, and the cross-modal world of synesthetes continues, different from the world non-synesthetes perceive, richer in some ways, more confusing in others, and the phenomenon persists. Skolem's paradox. Set theory describes infinite sets of different sizes, and Georg Cantor proved that the real numbers are uncountably infinite, that they cannot be placed in one-to-one correspondence with the natural numbers, that there are more real numbers than natural numbers, and this is one of the foundational results of modern mathematics, a theorem that establishes a hierarchy of infinities. But Thoralf Skolem discovered a paradox, or what appears to be a paradox, that threatens this result. And the paradox is that any consistent first-order theory that has an infinite model also has a countable model, a model where the domain consists of only countably many elements. And this is the Löwenheim-Skolem theorem, and applying it to set theory yields a troubling conclusion. If set theory is consistent, then it has a countable model, a model where the universe of sets is countably infinite. And yet within this model, the axioms of set theory are satisfied, including Cantor's theorem, which proves that the real numbers are uncountable. And so we have a countable model of set theory in which there exists an uncountable set. And this seems contradictory. How can a set be uncountable if the entire universe is countable? How can there be more real numbers than natural numbers if the whole model has only countably many elements? And this is Skolem's paradox. The resolution lies in understanding the distinction between internal and external perspectives, between how things appear from inside the model and how they appear from outside. From inside the countable model of set theory, all the axioms hold. Cantor's theorem is provable. The real numbers have no enumeration within the model. No bijection between the reals and the naturals exists as far as the model is concerned, and so internally, the reals are uncountable. But from outside the model, from the perspective of someone who can see the entire structure, the model itself has only countably many elements, and there exists a bijection between the elements of the model and the natural numbers. A bijection that is not itself an element of the model, that does not correspond to any set or function within the model. And so externally, the model is countable. And this distinction between internal and external is the key to resolving the paradox. Uncountability is relative. It depends on what bijections are available, and different models have different bijections. Skolем's paradox reveals something profound about the nature of mathematical existence and the limits of first-order logic. It shows that first-order logic cannot pin down the cardinality of infinite sets, that the concept of uncountability is not absolute but relative to a model, that what counts as uncountable in one model may be countable in another, and this relativity is a consequence of the expressive limitations of first-order logic, which can only quantify over elements of the domain, not over arbitrary functions or sets of elements, and so first-order set theory cannot express the existence of a bijection between two sets in an absolute way, cannot say, in a model-independent manner, that a set is countable or uncountable. Some philosophers and logicians find this relativity troubling, a sign that first-order set theory is inadequate as a foundation for mathematics, that a stronger logic, perhaps second-order logic, which allows quantification over sets and functions, is needed to capture the intended meaning of set-theoretic concepts. And in second-order logic, the Löwenheim-Skolem theorem does not hold. There are categorical characterizations of structures, including characterizations of the natural numbers and the real numbers that pin down their cardinality uniquely, and so second-order logic avoids Skolem's paradox by being more expressive, by allowing statements that distinguish countable from uncountable models. But second-order logic has its own difficulties. It lacks complete proof systems. There is no algorithmic procedure that can, in principle, prove all second-order truths, and so the gain in expressiveness comes at the cost of losing some of the nice logical properties that first-order logic enjoys. Others embrace the relativity revealed by Skolem's paradox, arguing that it shows the conventional or perspectival nature of mathematical concepts, that cardinality is not an intrinsic property of sets but a relation between sets and models, that what we call uncountable is simply a set that lacks an enumeration within a particular model, and that different models can disagree about what is countable without any of them being wrong. And this perspective aligns with a pluralistic or model-theoretic approach to mathematics, where there is no single intended model of set theory, but many models, each with its own internal structure, and what is true varies from model to model, and mathematical truth is relative to a choice of model. Skolem's paradox also connects to issues about the definiteness of the continuum, about whether the set of real numbers has a well-defined cardinality, and the continuum hypothesis, which asks whether there is a set whose cardinality is strictly between that of the natural numbers and the real numbers. And this hypothesis is independent of the standard axioms of set theory, meaning that neither the hypothesis nor its negation can be proven from the axioms. And some mathematicians interpret this independence as evidence that the cardinality of the continuum is not a definite matter of fact, but depends on additional assumptions or on the choice of model. And Skolem's paradox reinforces this interpretation by showing that even the distinction between countable and uncountable is model-dependent. The paradox remains a touchstone in the philosophy of mathematics and the foundations of logic. It illustrates the limits of first-order logic, the relativity of model-theoretic notions, and the gap between formal systems and intended interpretations. And it forces careful thinking about what it means to say that a set is countable or uncountable, about whether mathematical concepts have absolute meanings or are always relative to a framework and about the relationship between syntactic provability and semantic truth. And the paradox has no simple resolution. Different philosophers and mathematicians draw different lessons, some seeing it as a defect of first-order logic, others as a feature revealing deep truths about the nature of infinity and cardinality. And the debate continues, with implications for how we understand the foundations of mathematics, the status of set theory, and the nature of mathematical truth. The countable model sits in logical space, containing sets and functions and real numbers, and within this model, Cantor's theorem holds. The reals are uncountable, no enumeration exists, but from outside the model, the whole structure is countable. All its elements can be listed, and the real numbers of the model, uncountable internally, are countable externally. And this doubling of perspective, this split between internal and external, is the heart of Skolем's paradox, a demonstration that perspective matters, that truth is not always absolute, that models can disagree, and that first-order logic, powerful as it is, cannot capture all the nuances of infinite cardinality. And the paradox endures, a puzzle that has shaped logic and set theory, a challenge that continues to generate discussion and debate, and a reminder that even the most basic mathematical concepts, even the notion of how many, become subtle and contested when applied to infinite collections. The Allais paradox. Maurice Allais, a French economist and Nobel laureate, presented a pair of choices in 1953 that revealed a systematic pattern of preferences violating the independence axiom of expected utility theory, and this became known as the Allais paradox, one of the most influential demonstrations that human decision-making deviates from the prescriptions of standard rational choice theory. And the paradox shows that people's preferences can be influenced by irrelevant alternatives, by outcomes that occur in both options and should therefore cancel out, yet somehow affect which option is chosen. The first choice involves two lotteries. Lottery A offers a certain gain of $1 million, while Lottery B offers a 10% chance of winning $5 million, an 89% chance of winning $1 million, and a 1% chance of winning nothing. And when faced with this choice, most people prefer Lottery A, the certain million, preferring the sure thing to the gamble, even though the gamble has a higher expected value. And this preference reflects risk aversion, a common and generally accepted feature of human decision-making. The second choice involves two different lotteries. Lottery C offers an 11% chance of winning $1 million and an 89% chance of winning nothing, while Lottery D offers a 10% chance of winning $5 million and a 90% chance of winning nothing. And when faced with this choice, most people prefer Lottery D, the gamble with the higher potential payoff, accepting the slightly lower probability of winning in exchange for the much larger prize. The paradox emerges when these two preference patterns are analysed together, because the independence axiom of expected utility theory requires that if Lottery A is preferred to Lottery B, then Lottery C should be preferred to Lottery D. And the reason is that Lotteries A and B differ from Lotteries C and D only in that there is an 89% chance in both A and B of receiving $1 million, and in both C and D this 89% outcome is replaced with winning nothing, and this replacement should affect both lotteries equally, should not change the preference order, because the independence axiom says that preferences between lotteries should depend only on outcomes where the lotteries differ, not on outcomes that are the same in both. And the 89% probability mass is shifted in the same way for both pairs, and so if you prefer A to B, you should also prefer C to D. And if you prefer D to C, you should also prefer B to A. The typical pattern of preferences, A over B and D over C, cannot be represented by any utility function satisfying the expected utility axioms. And so the Allais paradox demonstrates that people systematically violate the independence axiom, that their preferences are sensitive to common outcomes in ways that expected utility theory does not permit. And this violation is robust, appearing in experiments with diverse populations, with real monetary stakes, with careful experimental design, and the paradox cannot be dismissed as error or confusion, but represents a genuine feature of human decision-making. The paradox has inspired alternative theories that can accommodate the observed preferences, including prospect theory, developed by Daniel Kahneman and Amos Tversky, which modifies expected utility theory by introducing reference points, by treating gains and losses differently, by allowing for probability weighting where people overweight small probabilities and underweight large probabilities. And these modifications can explain the Allais preferences, because in the first choice, the certainty of $1 million receives extra weight, making Lottery A more attractive, while in the second choice the small probabilities are overweighted, making the 10% chance of 5 million in Lottery D seem more appealing than the 11% chance of 1 million in Lottery C. Other theories include regret theory, where people anticipate the regret they would feel if they made the wrong choice. And this anticipated regret influences preferences in ways that violate independence, because the certain million in Lottery A avoids the regret of choosing the gamble and losing everything, while the choices between C and D do not have this asymmetry. And rank-dependent utility theory, which generalizes expected utility by allowing the utility of lotteries to depend not just on outcomes and probabilities, but on the rank ordering of outcomes, and this allows for preferences that violate independence while maintaining other desirable properties. The Allais paradox raises normative questions about rationality. Some argue that the independence axiom is a fundamental requirement of rational choice, that violating it leads to incoherence, to preferences that can be exploited through Dutch books or money pumps, to decision-making that is systematically suboptimal, and that people who exhibit Allais preferences are making mistakes and should revise their preferences to conform to expected utility theory. While others argue that the independence axiom, while mathematically convenient, is not a necessary condition for rationality, that it does not capture important aspects of how people value uncertain prospects, that preferences like those in the Allais paradox reflect legitimate concerns about certainty, regret, and the context of choice, and that we should revise our normative theories to accommodate these preferences rather than dismissing them as irrational. The paradox also has practical implications for economics and policy, because if people systematically violate independence, then markets may not function as standard theory predicts. Risk preferences may be context-dependent. Insurance and investment decisions may be influenced by framing effects, and policies designed to maximize expected utility may not align with what people actually prefer. And understanding these deviations from expected utility helps explain phenomena like the equity premium puzzle, the disposition effect, and other anomalies in financial markets and economic behavior. The lotteries sit before you, the choices must be made, and your preferences, revealed through your choices, tell a story about how you value certainty and risk, about how you weigh probabilities and outcomes, and the story violates the axioms of rational choice, violates the clean mathematical structure of expected utility theory, and yet the choices feel reasonable, feel justified, feel like they reflect something important about value and uncertainty that the theory misses, and the paradox persists. The gap between theory and behavior remains. The independence axiom is violated again and again in experiments and in life, and decision theorists must choose. Either insist that the axiom is normatively binding and that violators are irrational, or acknowledge that the axiom is too strong, that rational choice is more complex than expected utility allows, and that new theories are needed to capture the richness of human decision-making. And the Allais paradox remains a landmark, a decisive demonstration that classical rational choice theory does not fully describe or prescribe human behavior, a challenge that spawned new theories and new research programs, and a reminder that rationality is contested, that what counts as a reasonable choice depends on assumptions and frameworks that are themselves open to question, and the lotteries remain, the choices remain, the preferences remain, and the paradox endures, unsolved in the sense that no consensus has emerged about whether the preferences are rational or irrational, about whether we should revise our theories or our preferences, about whether independence is a negotiable axiom or a non-negotiable requirement. And the debate continues. Philosophers and economists and psychologists arguing about what rationality requires, about what humans actually do, and about the relationship between these two questions. The analysis paradox. Philosophy has long been concerned with analysis, with taking complex concepts and breaking them down into simpler components, with providing definitions that specify the necessary and sufficient conditions for the application of a term, and this project of conceptual analysis seems both important and straightforward. We want to know what knowledge is, what justice is, what truth is, and we proceed by analysing these concepts, by stating explicitly what they mean, by giving definitions that capture their essential features. Yet there is a paradox lurking here, a puzzle about whether analysis is even possible. And this is the paradox of analysis, first articulated clearly by C.H. Langford, and discussed extensively by G.E. Moore and others in the early 20th century. The paradox can be stated simply. Suppose we offer an analysis of some concept. For example, we might analyse the concept brother as male sibling, and this analysis, if correct, should be informative, should tell us something we did not already know about what brotherhood consists in, should illuminate the concept by making its structure explicit. But if the analysis is correct, then the analysandum, the concept being analysed, and the analysans, the analysis itself, must have the same meaning. They must be synonymous, otherwise the analysis would be incorrect. It would not capture what brotherhood really is. And if they are synonymous, then the statement brother means male sibling should be trivial, should be like saying brother means brother, a mere tautology that provides no new information. And so the analysis cannot be both correct and informative. If it is correct, then it is trivial. And if it is informative, then it is not a genuine analysis, but merely a stipulation or a proposed change of meaning. The paradox threatens the entire project of conceptual analysis, because it suggests that analysis cannot do what it is supposed to do, cannot both correctly identify the meaning of a concept and provide new insight into that meaning, cannot be both true and interesting. And so either conceptual analysis is impossible, or our understanding of what analysis is and what it aims to achieve must be revised. One response to the paradox distinguishes between sense and reference, between the meaning of a term and what it picks out, and argues that an analysis can be informative even if the analysandum and analysans refer to the same thing, because they can differ in sense, in the way they present or describe that thing. And so the analysis brother means male sibling is informative, because even though brother and male sibling refer to the same set of individuals, they present that set in different ways, one as a family relation and the other as a combination of gender and kinship. And this difference in sense makes the identity statement informative rather than trivial. Another response appeals to a distinction between conceptual and factual knowledge, arguing that analysis does not provide factual knowledge about the world, but conceptual knowledge about our own concepts, that it makes explicit what was already implicit in our understanding, that it brings to consciousness the structure of concepts that we already possess and use, but have not fully articulated. And so, the informativeness of analysis is not the informativeness of discovering new facts, but the informativeness of self-clarification, of making our own conceptual commitments explicit and transparent. A third response associated with Quine and others skeptical of the analytic-synthetic distinction denies that there is a sharp line between conceptual analysis and empirical investigation, arguing that all beliefs form a holistic web where conceptual revisions and factual discoveries are intertwined, and that what we call analysis is really just careful reflection on our current best theory of the world, subject to revision in light of new evidence or theoretical considerations. And on this view, the paradox dissolves, because analysis is not supposed to be a priori or purely conceptual, but is continuous with empirical inquiry, and so it can be both correct and informative without any mystery. The paradox also raises questions about the methodology of philosophy, about whether philosophy can make progress through analysis or whether some other method is needed. And different philosophical traditions have taken different stances, with analytic philosophy traditionally emphasizing conceptual analysis as a central tool, while continental philosophy has been more skeptical of analysis, focusing instead on interpretation, critique, and phenomenological description. And the paradox of analysis has been one factor driving some philosophers away from traditional analysis toward other approaches. The paradox connects to issues about understanding and competence, because we seem to have a kind of implicit or tacit understanding of concepts like knowledge, justice, and truth. We can use these concepts correctly, can apply them to particular cases, can recognize when they are used inappropriately, and yet when asked to state explicitly what these concepts mean, to provide a definition, we struggle. And this suggests that conceptual competence does not require explicit knowledge of definitions, that understanding can be practical and procedural rather than theoretical and propositional, and that analysis attempts to convert implicit understanding into explicit knowledge, a conversion that is difficult and perhaps impossible to complete without remainder. The paradox also appears in the context of philosophical disagreement, because philosophers have been offering analyses of key concepts for millennia, and yet consensus remains elusive. Different philosophers provide different analyses of knowledge, of justice, of truth, and it is not always clear how to adjudicate between competing analyses, whether by appeal to intuitions about particular cases, by considerations of theoretical simplicity and fruitfulness, or by some other standard. And the lack of agreement raises the question of whether these concepts have determinate meanings that analysis can discover, or whether they are vague, contested, or essentially contested, such that no single analysis could capture all the ways they are legitimately used. The analysis paradox remains a puzzle at the heart of philosophy, a question about what philosophy is doing when it offers definitions and analyses, whether it is discovering pre-existing meanings, stipulating new ones, or engaging in some more complex activity that combines elements of discovery, stipulation, and rational reconstruction, and the paradox has not been definitively resolved. Different philosophers find different responses more or less compelling, and the debate continues, with implications for how we understand the nature and methods of philosophical inquiry. And the concept sits there, waiting to be analysed, inviting us to state its essence, to specify its conditions, to make explicit what we already implicitly know, and yet the analysis, when offered, seems either to tell us nothing new or to change the subject, to offer a different concept rather than clarifying the original one. And the paradox persists, a thorn in the side of analysis, a reminder that understanding is more elusive than it appears, that the gap between knowing how to use a concept and knowing what it means is wider than we thought, and that philosophy, despite its ancient commitment to clarity and definition, to making the implicit explicit and the confused clear, may be chasing a goal that is inherently problematic, inherently paradoxical, a goal that recedes as we approach it, that becomes more obscure the more we try to illuminate it, and yet we continue to analyse, to offer definitions, to seek clarity, because the alternative, giving up on understanding, seems worse.